this is a good problem because I'll show you why I think it's a good problem. But for this one, it says bond X is a 20-year bond with this with a bond. So there's a par value of 1,000, annual coupon rate of 0.10, and bond X is callable at par on any of the last 5 coupon payments. Okay, and they give us a range, right? And we want to calculate the maximum purchase price of bond X that will guarantee. Well, again, the terminology maximum purchase price, that does not necessarily mean the highest price. That actually means the lowest price. Maximum purchase price is a fancy way of saying lowest price in the actuary world. So now it says will guarantee an annual effective yield rate of at least 5%. So, well, yield rate is 5%, coupon rate is 10%. What does that mean? That means that this bond is being sold at a premium. What does that also mean? This bond has to be called at the earliest date possible. They give us a range of the last 5 coupon dates that this bond can be callable at, right? So again, we can set up an equation. So this A at annual effective yield of 5% plus 1,000 V to the, okay, so this is where it gets cool. This is a good problem because it says that it's callable at par on any of the last 5 coupon days. I initially used 15 as the number of years. Why? Because I just did 20 minus 5. But no, that's wrong. In order to be very accurate, we're gonna you have to be sure that what the numbers that you're choosing are correct, right? But you see here that, well, what are actually the last 5 coupon dates, right? If each coupon date is occurring at the end of the year, well, let's see, 1, 2, 3, 4, 5. It would have been 15 if coupons were occurring at the beginning of each year, but that's not the case. So therefore, the earliest date that we need to call on, since it's a premium bond, is at 16. Now, let's do 1,000 times 0.10. We're going to get 100 here, right? So now let's use the TBM to compute this bond pricing formula. So it'd be 100 as the payment, 16 as the number of years, 5 as the interest rate, 1,000 as the future value. We're going to compute the present value, and we're going to get 1,541.89, which will be the answer.